Okay, let us do some compounding of interest and another rogue question as well. Let's start with number 5 up here. We have a principal, an annual rate, a time, and we know that it's compounded continuously. So that compounded continuously should tell you something. It should tell you that you want to, whoops. That's a great start. Okay, let's try again. It should tell you that the amount after all the interest is compounded is going to be equal to the principal times e to the RT. Your principal amount is 5,600. E is just a number, it's in your calculator. You hit second and then LN, which is kind of towards the bottom left, and it'll get you E with an exponent. And then the rate, 0.0582. And I want to take a second real quick to point out that 0.0582 is simply 5.82 divided by 100, which would move this decimal 2 places. And the reason we do that is because percent means out of 100, so 5.82 out of 100, so we divide by 100. All right, and then how long is that annual rate being compounded? For 25 years. And when you plug that into your calculator, you will get about $23,933.11. And that's number 5. Number 6 causes some trouble, but that's okay. We can make it work. Let's look at it. We know a couple things. We know we're compounded quarterly, which means we're going to use a different formula than the one we used up top. The one up top would give us a decent estimate, but it would be a little overshot. Or I guess it would tell us it wouldn't take quite as long as it really would. Okay, so we have R over N to the NT. So we need to plug in some values there. Well, we don't know what A is, we don't know what P is, but we do know what the rate is. 0.07 divided by 4, because we're compounding quarterly. There are 4 quarters in a year. So if this is a yearly rate, we need to divide it by 4, because that's how many times we compounded that. And then it's raised to the 4 times time, which we don't know. That's what we're trying to find out. Okay, so how do we get rid of this A and this P business? Well, we have to realize something, that it tells us we want to double our principal. So the amount that we get over here should be twice as much as the principal, twice as much as P, also known as 2P. And so when you know that you can divide by P on both sides, and your P's don't matter anymore. What this tells us is that 7% compounded quarterly is going to double any amount of money at the same speed. So it's going to make $2 into $4 the same amount of time it takes it to make $100,000 into $200,000. Doesn't matter the amount, it just matters the rate and how often it's being compounded. So now we have 2 sides of an equation. So what we're going to do is, in the future, we're going to use a logarithm to kind of undo that exponent. But for now, we'll go to the calculator, and we're going to put in both sides of our equation into y equals. So one side of the equation was 2. And so we wanted to know when we were going to double. So we wanted to know when will 1 plus 0.07 divided by 4 raised to the 4t, which we're not using t, we're using x. We want to know when those will equal each other. So let's graph. And when they equal each other on a graph, that is also known as the intersection. And the way we find the intersection is we're going to hit second, trace, 5, We'll hit enter 3 times, and it'll tell us 9.988, or 9.99 years. Let's go back. So the amount of time is equal to 9.99 years. You could round that up to 10, I guess. All right, let's jump to number 7. Number 7, we're not talking about money anymore. And this morning I just had a time with it. We're not talking about money anymore. We're just talking about an exponential function. Something is equal to a times b to the x. So y depends on x. So if x is the amount of time we've been decaying, y is going to tell us how much we have left. Half-life of something is just the amount of time it takes for half of, so if we have 12 milligrams, what it's saying is it's going to take 64.128 hours for that 12 milligram sample to become a 6 milligram sample. Okay, so we're slowly getting less and less of this mercury 197. Okay, so we need to form an equation. Our final amount, which I'm going to call y, you could call it a, you could call it a bunch of different things. Our final amount is equal to the original amount. Remember, that's what a is. That's our y-intercept. It's where we started. So 12 times b. B is our constant multiplier. What's our constant multiplier? Half-life. So our constant multiplier is 1/2. Okay, and then what number is going to go up there with the x? Well, we're not going to use 72 and we're not going to use 64 because those are hours. We want to know how many half-lives. The x, or the amount of time, is going to be the number of half-lives. And so we need to use (72) divided by 64.128. And you're like, what? Okay, please don't be like, what? Okay, so how long would it take me to get one half-life? 64.128 hours, exactly. But I have a little bit more than that. I have 72. So I'm trying to find out how many half-lives I have. So I take 72 and I divide it by 64.128. And in the end, you get that you will have 5.51 milligrams of mercury in 72 hours. Okay. My goal, I'm going to try to do just one more on this video. And if you have questions, maybe I can answer them tomorrow. All right, so we have maybe Kaya and Nikki. They're investing $2,000 with an annual interest of 5.5%, and it's compounded semi-annually. In most classes, we talked about that 2 times per year. How much will Kaya have in her account in 10 years? Well, we're going to use an equation. We are not going to use PE to the RT because it's not compounded continuously. We're going to use P is 1 plus the rate over the number of times we compound in a year raised to the number times the number of years. So we've got $2,000, 1 plus the rate, 0.055, divided by semi-annually, so that's twice, raised to the 2, and we are times 10. So the amount is going to be, you plug, you chug, you get $3,440.86. I'm going to go green for the last one. How long will it take for her account to reach $5,000? Okay, well, what's 5,000 in our equation? This equation right here. Which one should be 5,000? That's her final amount, right? So 5,000 equals 2,000 times 1 plus 0.055 over 2 to the 2t, because now we don't know what t is. All right. Now here we have a formula that we could simplify with a logarithm and solve. But for now, we're just going to use the calculator. You plug 5,000 over 2,000, that's just 2.5, into one side, and you plug this part that's left into y1. You plug this into y2, and you find the intersection. And the intersection is t equals about 16.9 years. All right, thanks for watching. Good luck, and see you tomorrow.